Good morning. Today we are going to solve some easy questions. So let's start from the question that is, so that the function fx is equal to 2x minus mod x is continuous at x equal to 0. Sometimes some functions are not ready to test the continuity. So that's why before testing the continuity, before getting the limits, we are supposed to simplify the given function. So for that, I start from that is solution. We have, let's remember your modulus function. So that is mod of x is equal to, if x is greater than or equal to 0, then the value of mod x is x, and if x is less than 0, then it is minus x. So here we are required to use it. Then the given function fx, which is actually 2x minus mod x, it is equal to, now it reduces to, if x is greater than or equal to 0. So what is changed there? It remains same, 2x minus, what is the value of mod x? Now it becomes x, and in this case, if x is less than 0, so 2x remains same, minus is minus, this minus, at the place of mod x, here we are required to put minus x. So on simplification, we get this case our function fx is equal to, that is x, 2x minus x, if x is greater than or equal to 0, and if x is less than 0, then minus minus plus, it becomes 3x. Now let's start writing, that is left hand limit, it is equal to limit x tends to 0 from left fx. Since function is divided for more than x, less than x, so here it is not required to use the term h. Directly we can put the value of the function less than 0, and in case less than 0, actually it is 3x. In that case, limit changes to x tends to 0, and when we take the limit, we get 3 into 0, and it is equal to 0. Similarly, we get right hand limit, and it is equal to limit x tends to 0 from right fx, and it is equal to limit x tends to 0. What's about the definition of a function for more than 0? It is actually x, and it comes as 0. Finally, the value of the function at x equal to 0 equal to 0, we write, therefore limit x tends to 0 from left, it is equal to limit x tends to 0 from right, and it is equal to the value of the function at that point. All three are 0. So function fx is continuous at x equal to 0. So it is very simple to get left hand limit as well as right hand limit and the value of the function. If all three equal, then we say it is continuous, otherwise it is discontinuous. Just take some other questions. Here going to take a question that is, let function f is defined as, if x is not equal to 0. The function is defined as sin x by x plus cos x when x is not equal to 0, and when x is equal to 0, its value is 2. Okay, now so that the function, f is continuous at x equal to 0. So this is the question. Function is defined, only we are required to get left hand limit and right hand limit. This is part of solution. We have fx is equal to, that is sin x by x plus cos x. X is not equal to 0, and if x equal to 0, its value is 2. Now left hand limit, it is equal to, by definition, the limit x tends to 0 from left. Simple, we write, if x tends to 0 from left, then we get what? Left hand limit. And similarly we find right limit. So in this case, function is not characterized for more than 0 and less than 0. Only it is given it is for not equal to 0, so we are supposed to use h. So here I write it is equal to limit h tends to 0, and there is a change in 0 minus h. This is a common value of the function. For not equal to 0, it means the same thing is for more than 0 and same for less than 0. So from here we get, that is limit h tends to 0. Function is this, in this case. So we write sin, at the place of x it is 0 minus h divided by, that is 0 minus h, plus cos, at the place of x it is 0 minus h. Simply we put 0 minus h at the place of x. Now when we simplify it, then we get, that is, as we know, sin of minus theta equal to minus sin theta. So that's why from here we get minus sin h, and it is minus h. So minus minus cancelled out, we get sin h by h, plus cosine of minus theta equal to cosine theta. That's why we get cos h. Now separate the limits. H tends to 0, sin h by h, plus limit h tends to 0, that is cos h, and it is equal to 1 plus 1, it is equal to 2 by the formula, by the results of limits. What's about right hand limit? It is right hand limit, and similarly we get x tends to 0 from right, and this is the function. Again we take limit h tends to 0, f of the point is 0, and it is plus h. Again fx is the same for more than 0 as well as less than 0. So we get it is equal to, that is limit h tends to 0, writing sin 0 plus h divided by 0 plus h, plus cos 0 plus h. And when we simplify, then we get it is equal to limit h tends to 0, it is sin h by h plus cos h, and again we get it is equal to 1 plus 1, it is by formula, it is also by formula, and it is equal to 2. Now what's about the value of the function at x equal to 0? So we write also f of 0 equal to 2. So thus limit x tends to 0 from left is equal to limit x tends to 0 from right, and it is also is equal to the value of the function at that point, since all three becomes equal to 2. So we write therefore fx is continuous at x equal to 0. So sometimes when the function is not characterized for more than that point, less than that point, in that case we are bound to use h. Otherwise, if it is characterized, then directly we take that function. Now, taking some other question that is having 4 marks. So let function f is defined as if x is less than 0, then the value of the function is 1 minus cos 4x divided by x square. If x is equal to 0, then here its value is given as a. If its value is more than 0, then here it is defined as, that is, root over x divided by root over 60 plus root over x, then minus 4. This is about the function. These 3 conditions are there. Then what we are required to find, what we are required to do. So here, determine the value of a so that fx is continuous at x equal to 0. Here directly it is given the function is continuous at x equal to 0. So using the concept of continuity, we are supposed to get the value of the given constant. Here the given constant is a. Since fx is continuous at x equal to 0, therefore limit x tends to 0 minus is equal to, that is, x tends to 0 plus, and it is equal to the value of the function at that point. Make it equation number 1. So first we find left hand limit, then we find right hand limit, then we get the value of the function. At that point, when we equate, then we already get some relations, and after solving or directly we get the required value. So I am dividing it into 2 parts. I start from here, that is, limit x tends to 0 is fx. Since here our function is characterized, this is for less than 0, this is for more than 0, so we are not required to use h. If we use h, then we get the same thing, but here we try directly less than 0, so just take less than 0, so replace f by 1 minus cos 4x divided by x square, and remove here minus. Since we know x tends to 0, 1 minus cos 2x is 2 sine square half of this angle, that is 2x whole divided by x square. To fit in our results of limits, we are required here, that is 4. So into 4, and that is into 4. So we get it is equal to, take out the constant, that is 2 into 4, that is 8. It can be written as limit x tends to 0, and this is sine 2x divided by 2x whole square. Since it is sine of 2x, that's why here it is required square of 2x. So it comes as, it is equal to 8 into 1. By the formula, it is equal to 8. Similarly, we get right hand limit, that is limit x tends to 0 from right. It is characterized here for more than 0, so we write limit, write the value of function for more than 0 and remove the plus sign here. So we write, that is root over x whole divided by root over 16 plus root over x, then minus 4, and it is x tends to 0. Now it is time to solve the limit. How we solve? by earlier processes. So ways by rationalization. Rationalization means what? We are required to multiply numerator and denominator by the conjugate of the denominator, since it is of the form 0 by 0. So after removing that form, we are required to take the limit. So that's why we multiply it by the conjugate of denominator. Conjugate means only we change the sign. So we get root over 16 plus root over x plus 4. For balance, same thing, that is root over 16 plus root over x plus 4. When we multiply it, then definitely we get, that is the denominator of the form a minus b and a plus b. So it can be written as a square minus b square. So we get square of this 16 plus root over x minus square of second one 4 square, that is 16, and in numerator no change, root over x into, that is root over 16 plus root over x plus 4. Now 16 out, root x out, we get limit x tends to 0, root over 16 plus root over x plus 4. Now we may take the limit, and putting x equal to 0, we get, that is 4 plus 4, this is equal to 8. Now f of 0 is equal to a, therefore by equation 1 we get, that is x tends to 0 from left, it is equal to x tends to 0 from right, and it is equal to a. It implies 8 equal to a, it also implies a equal to 8. So what is the value of a? 8. Since it is easy, here we are having only one variable. In case when two variables are there, then we get linear equation, but here it is required. You are required to find left hand limit as well as right hand limit, not only one to get the value of a as 8. So that is wrong. We solve both and d came as 8, then putting 8 we get a. Okay, next video we solve some more questions.